Well, another installment of another tornado series in Medina.
And we're getting into
right?
August now. I'm doing these violent tornadoes in North Dakota history kind of in chronological order, but now that these tornadoes in our history are in August, that's a little bit on the later end of the severe weather season. Usually we see any of these strong tornadoes happen in late June to early July, but they can happen in August. This is a map of all the violent tornadoes in North Dakota's history, F4, EF4, or stronger. And again, we're going to be focusing on the Medina tornado today, which happened on August 11th, 2002. It's the third latest tornado to happen in the calendar year because of F4 or stronger strength in North Dakota. There was two other August tornadoes that happened in the eastern part of the state. Now, this one happened on August 11th, 2002. It was a Sunday that year with a couple of farmsteads taking the brunt of this tornado to the north of Medina. One of them was completely destroyed. You can see how vehicles were tossed like toy cars. This pickup truck was thrown on top of a John Deere tractor. Fortunately, no injuries or fatalities, but a family pet was killed in this tornado. And again, it happened to the north of Medina by about 5 miles. It was only on the ground for about a mile, lasting 10 to 20 minutes, but it was 400 yards wide, which is relatively large in terms of the width of the tornado for North Dakota standards. Some of the other damage that was done to these farmsteads to get that F4 rating, which is with peak winds of over 200 miles per hour. It's a 9-ton grain truck, which I believe that these photos show is moved 250 feet and destroyed. 3 other vehicles were moved several hundred feet and heavily damaged, and the tornado also destroyed 5 transmission towers. Now, Chauncey Schultz was on the damage survey, one of his first damage surveys that he was on with the Weather Service, and he describes the level of damage that this tornado caused.
I remember being at this particular damage survey as a student volunteer back in the day, and the immense destruction, especially at the one farmstead where the house was completely demolished, really stood out to me. That particular farmhouse had a root cellar off to the side of the basement, and the 2 grandparents were home at the time with 3 grandchildren. They all had enough warning that the tornado was coming that they crawled into the root cellar. Not only were there no fatalities with this tornado, but none of them were injured either because they took advanced alerts. Their house was completely destroyed, and all you can see is this hole leading into the root cellar left in the basement with debris filling the basement. And it really resonated with me that getting the alert, crawling into that root cellar, led to the result of 5 lives being saved.
Just incredible, the story there from that family, as well as the degree of damage that this tornado did in order to get that F4 rating. The Fujita scale was upgraded to the enhanced Fujita scale in 2007. So again, this tornado was rated on the old scale, with the wind speeds being a little bit higher for each of those ratings. The different levels of damage, or the damage indicators, have changed a little bit as well as the F scale to the EF scale was upgraded, and Chauncey describes that process.
We've now transitioned to the enhanced Fujita scale, although a lot of the damage indicators are similar. We've added damage indicators. They've used engineering studies to better define what wind speed causes damage at certain levels, but we know that we can compare and say it was an F4 tornado. It likely would have been an EF4 tornado on the current scale, although the peak wind speed associated with it was probably a little less than what we thought in the old Fujita scale. More damage indicators leads to more precise ratings, and we have a better idea what the actual wind speeds are associated with in the enhanced Fujita or EF scale, which is what we've started using since about 2007.
And in order to produce a violent tornado of F4 caliber, we need to have the right ingredients in place over North Dakota. There was a triple point nearby, and what that is where 3 air masses meet. So there's a series of fronts nearby providing a lot of lift, but you have an air mass behind the cold front, one to the south of the warm front, and then another one between the occluded and warm fronts. Out ahead of the cold front, where Medina was, dew points were in the low 70s, very humid air, giving enough moisture for these storms to form and turn severe. Temperatures were rather warm as well, in the mid to upper 80s. But again, that triple point concentrates the energy and the ingredients for these violent tornadoes to form, enhancing the shear, lift, and instability, which are the key ingredients to get a supercell thunderstorm that produces a radar signature like this, with a tight couplet with strong winds, spinning in different directions in a counterclockwise flow there, but you can see how that strong indication on radar led to this violent tornado, and Chauncey kind of describes the radar evolution of that day.
It formed from a supercell thunderstorm that actually originated sort of out of a line of storms that was there. And suddenly the supercell thunderstorm, the rotation really rapidly intensified, produced this tornado. It was pretty highly visible from certain angles. I've heard of folks that were traveling along the interstate back in that day and watched the tornado. They were able to get the tornado warning out as it developed, but in a sense it was a small scale weather pattern, one storm that produced the most highest end tornado in this particular event, something that we have seen in other tornado events that have happened in North Dakota over the years.
And only one tornado was reported in North Dakota that day on August 11, 2002, this Medina F-4 tornado. Chauncey will describe here why sometimes we see tornado outbreaks with numerous strong to violent tornadoes across the state, and other times it's just one violent tornado like in this situation.
A lot of times we see the ingredients that results in supercell development being focused over a small scale area in North Dakota. We really want isolated supercell forming in a high shear environment to be capable of producing tornadoes. Sometimes that happens over a larger scale that results in that outbreak kind of scenario. But it seems like more often in North Dakota, we're just on the edge of maybe that warm mid-level capping inversion that we talk about, where there's just enough energy to let a thunderstorm to develop and become isolated, that supercell kind of form, and then maybe go on to produce a tornado. Other times, in our part of the world, the storms tend to form into lines. Lines of storms, like a derecho, are less frequently associated directly with higher end tornadoes than an isolated supercell thunderstorm. And so very nuanced stages of these ingredients coming together, leading to the development of the tornadoes.
It's really interesting researching these events, picking Chauncey's brain since he's worked here for so long
Right.
and been on damage surveys or issuing the warnings for these violent tornadoes over the years, and just looking back at how the setup produced this caliber of a tornado and then the damage that was unfortunately done.
So amazing how long ago it was, right? And just thinking back to I don't remember this one in particular.
23 years ago.
Yeah, 23
I
years
feel
ago.
like
Amazing.
if I saw that in real life, I would never forget it. I do
You
not ever
would
need to
not,
see that in
right?
real life.
That was
No
so
way.
close, right? And hopefully tomorrow we might have some discrete supercells early on before it becomes a line, but stay weather aware, active season.
Definitely.
All right,
Yeah,
thanks, Jacob.
Yeah, thank you.